Okay, so this is an update from a video I posted a couple months ago that walked through how to use the Python API for the RPiSoC. There have been a number of updates since then. Things are a little bit different. There's documentation that reflects all those changes, but I figured I'd redo the video tutorial to kind of show some of these updates and show kind of some new things that you can do. So I have laid out here a whole bunch of different I/O, basically. Some NeoPixels you'll see. We got motors, we got analog, we got so a bunch of I/O over here, and we'll be doing a number of other things, little buzzer. So I'll get into all that, try to get through it as quickly as possible. So you know that I'm going to be running this from my Windows computer. I'm running Windows 7. I'm running it through a USB cable. Alternatively, you could run it on the Raspberry Pi. You just use a different communication protocol, but everything should be exactly the same regardless. It's just easier to capture the video from my computer. So the first thing you're going to do is you're going to import your dependencies, which should be the same as normal as before. Do it just like that. Then you will tell the RPiSoC how you're going to be communicating with it, just like that, which is what we did before, except this time I'm using serial. If you're on the Raspberry Pi, you would use probably SPI. You could also use I2C. So once you do that, there's a new thing you can do, which is put on this little debug flag. This is going to give you some type of output to reflect debugging information. So the first thing you'll see that happens is we get all this kind of these analytics based on what the Python is seeing inside your firmware. So here's some analog information. It gives you a bunch of information about your PWMs and the clocks that are kind of driving them. It shows you what GPIO it finds. And the idea here is when you make changes to the firmware, you want to confirm that those changes are reflected in these analytics. Because if they're not, then there's going to be a problem, because this is what the Python's seeing. So you got to make sure that it's reflected here. Anyway, so moving on from that, first thing that's kind of different is our general purpose I/O. So the way you did things before is you would create an object called like a digital output or a digital input, and then you're kind of limited in that respect because you had a fixed number of inputs and outputs. So we changed that, and you can now just use any of your pins for any purpose. So we have out equals digital pin, for instance. Now you use this for all objects, and now you can do you have a port, a pin, and then a configuration that you give it. So let's use port 2, pin 0, and let's make it an output, which you would do like this. You can check the documentation for how to give it the config parameter, and you can do like input, output, pull up, pull down, open drain, driving high, open drain, driving low, number of different things. So we're just going to do a normal output here, just like that. Okay, and now there's an output, you can use the output method. So you could do out.write 1, and we should see that one connected to port 2 pin 0 is on now. And we can, of course, because it's an output, you can read it, see that it's true. You can then write 0, of course. So take that, write 0. Now it's off. You can toggle it. And so it'll just go to the opposite of whatever it currently is. Toggle it back off. Simple enough. And then you could do some cool like Pythonic type stuff. You know, because that's the reason that you put these types of things on Python, because it's fun. So we could do something like port 2. We can make a list of digital pins. Like, let's say digital pin 2. Let's say port 2, pin X as an output. And we'll do that for X in range 8. So this will be a list of pins in port 2. Cool. So now we have that, and now we can do stuff like we'll do a for loop 10 times or something like that. So let's do a for loop 10 times, and then for pin in port 2, you can see why Python's cool, because this is very expressive. So for all pins in port 2, we can do something like pin.toggle. So we can toggle every pin in port 2, and then wait some amount of time. So we'll wait 0.1 seconds, and now you can see it'll do that 10 times. Those are all connected to port 2, of course. So yeah, pretty easy. That's basically how you're going to use I/O. There's not that much to it, but the idea is that it's pretty easy to use, pretty flexible.